Good afternoon, students. Today we are going to see optimization problem solving. In earlier lectures, we have discussed about evolutionary computing, right? In that, as we all aware about, we are utilizing biological concepts like evolution and other things, which already we have discussed. So we can say that evolutionary computing is inspired by biological concepts, but what we are going to do with those concepts, we are utilizing those concepts for solving the optimization problem. So here I want to discuss about what is optimization problem solving. So basically, we will be having feasible solutions with us. So it is also called as candidate solution, or we can say we will be having a set of all the possible solution. And this set is called as search space, or as earlier lectures we had just considering it as a population. So alternatively, you can use any of this word, search space or population. So what is the goal in this case? Basically, we start with the real world problem. That real world problem we try to solve with the help of available model, right? So whatever model we are having, that is solution model, it will provide us solution, but it is not sure that that will be the best solution. So this, in this case, what we need to do, we will be having multiple solution by utilizing different parameters. There are so many things which if we change, then we get the different solutions for that, and out of those solution we need to select the best one. So how we can select that one? So for that purpose we can utilize this evolutionary algorithms to get the best optimal solution from all the feasible solutions. Selection of any particular solution based on the fitness value. Wherever you are finding the high fitness value, you are selecting that solution. But there are less chances of getting selected weak fitness value solution also. So whatever values or solution you can say are being selected, that will be utilized for the further production of the new offsprings, and or whoever just qualifying that fitness value, those will be going to the next generation. So here also I have mentioned that the solution are marked by the value called as fitness. Okay, so that on that basis only we are going to select our solution. So here we are checking that best solution, which is also a part of your search space only. But generally what happens, we define whenever we are solving our problem by using any particular solution model, there we define our objective function. Okay, so based on that objective function we have to decide which value is the best one, because that objective function gives us the goal, that is like minimizing that particular objective function or maximizing that objective function. So based on our goal, minimization or maximization, we will be selecting our best solution. So according to the value we are mapping that fitness, whether it is minimum or maximum, and then based on the that fitness value, finally we are getting our best solution. Okay, if you go to like just utilize the traditional models, there are various techniques available for the optimization problem solving, which are traditional one. We are going to see that one in next few slides. So here. If you use those one, it is not sure that you will be having all the possible solutions with you, but if you are using genetic algorithm, you will be having more possible solutions, because it evolves with each iteration and it will provide you best solutions in every iteration, like it is adding on. So it will be better to use this technique and utilize it for the optimization problem solving. So this is about the basic optimization problem solving. Now we will just learn how to define optimization problem. So basically, you need to define your objective function. Here in this slide, you can see this f of x will be your objective function, and that will be minimize. Here specifically I have written minimize. That will be my goal, but you can decide, it depends on your problem. Okay, that can be maximize also. So once you define your objective function, your goal, that is minimization or maximization, and it will have some functional constraints with it. That is, in this case, gi of x is less than equal to 0 is shown, and hj of x equal to 0. These two are the functional constraints. So you can say gi of x is an inequality constraint, and hj of x equal to 0 is an equality constraint based on the operators we have utilized over here. Okay, again, one more thing, whatever parameters you are setting, you can give the condition for that also, as here m and p values it is given. So like that also you can provide in your problem optimization problem definition. Okay,